share the information with you. Maybe you can listen to it while you're, I don't know, doing something else, folding laundry. All right, I think it's important to understand what the role of science is in our lives. And that is really about improving our lives individually, as a society as a whole, and globally. The nature of science in our lives is where we systematically gather information through a variety of forms of direct and indirect observations and testing the information. And we use these methods to experiment, to learn from this. And the effect, therefore, of science in our lives is having the end product, things like technology, medicine, and food, or in some cases, supplements. All right, the scientific method, folks, is just as a little review, if you're not familiar with it, is we initiate with a problem. And, there's a possibility that problem could be something like, people are dying at accelerated rates of heart disease. Now we formulate a hypothesis. It might be something to the effect of, you know, does vitamin E reduce incidences of heart disease? And then we design the experiment where we give people vitamin E supplements and we monitor their hearts and performance, exercise. We collect that data. We're going to analyze it and come to a conclusion, either to accept the hypothesis or to refuse it. And why do we do this? Because we want to solve a problem or address a question that we have. But what it needs to be is evidence-based. And evidence-based, folks, is empirical science. That's where we gather information by observation, or preferably the evidence. When we talk about nutrition, evidence-based is vital, because we have living humans, and whatever we do, it impacts our health and well-being. So we need it to be evidence-based to accept the information. Okay, this page, I'm just, you can look over and read on your own, because I'm not going to emphasize this topic. This is a great example of why does the color change in green beans, and performing a study on that. The research design terms, I cannot emphasize enough. I strongly encourage you to print this and keep this, because for now, in the future, reading a newspaper article, anything that's out there, so that you have a great little review to understand the different types of studies. And we'll talk about those in a moment. There are different ones and they have different qualities. When we're talking about laboratory-based biochemistry, studies are going to be things that are in vitro, utilizing test tubes, dishes. Molecular biochemistry, folks, this is now looking at people's DNA, understanding how their DNA is altered, anything around the genome. The Dutch winter study is an excellent example where we discovered that the dietary intake of people actually influences our DNA and how it's expressed. Therefore, nutrition does define our DNA, and it defines how it communicates to reproduce cells. There are animal-based studies. Why do we do this to animals? Well, it's never ideal to test on any living creature, but they are highly cost-effective. Animals have much shorter lifespans, so we're able to see start to end much more quickly. It's an easily controlled environment. Humans are challenging, and the biological variability can be controlled through breeding and DNA manipulation of the animals. Those, if you recall, are our little agouti mice. Animals that we typically use in studies are mice, rats, pigs, guinea pigs, monkeys, but it's not limited to those. I mean, rabbits are often used in studies also. So there's a variety of different animals. And please understand, I'm not saying that I advocate this. But on the other hand, I have to acknowledge that it gives us vital information. Historical successes? Well, folks, that's how we discovered vitamins and minerals, how we were able to learn more about our micronutrients, how we were able to identify diseases like beriberi, being a thiamine deficiency, or pellagra for a niacin deficiency. We would not have learned these folks without having studies. Those just happened to be initially human studies. And learning how, uh, through studies, diet can play a role in biological functions in human beings. All right. When we talk about clinical studies, folks, these are randomized clinical control trials are the gold standard. If they are double blind, meaning the researchers do not know what the control group is taking, and they also do not know what the treatment group is taking, and the people therefore also do not know. So everyone is assigned these random numbers. They're given ID numbers, and the people performing the studies don't know what goes to what. And then they're given pills, for example, and all the pills will be identical, whether it's the placebo or what they're studying, so that the patients don't know, and the people conducting the study have no idea. This, folks, is the highest quality study possible. The conundrum is uh, they're highly expensive because of that control. They do take a long time to complete. Um, They can provide for us, though, on the other hand, true incidence rates and relative risks, and the outcome could be measured after exposure. Uh, Typically, it's the pharmaceutical industry that practices these studies because they are horribly expensive, and that's where the money goes for research and development. There are clinical trials. You can go to the clinicaltrials.gov if you're ever curious and you want to participate in one. That would give you an opportunity to find out what they're currently studying, and if you want to become a part of clinical trials. Some are totally harmless, and some I would be concerned. Just keep in mind that clinical trials typically are performed on men, and secondary to that would be women. All right, another type of study are epidemiological, disease-based. We've got observational and longitudinal. So we observe over time is what that means. Cohort studies are going to be a group of people who carry something in common, and we might look forward in time. So let's say you do a study looking at pregnant women and their fish consumption, and then you monitor the children going forward for years to decades to see how it affects their behavior, their ability to perform standardized testing. Case control studies, folks, are retrospective, meaning we look back in time looking for information and identifying. So that would be where we pull together a group of people and we interview them, trying to establish information like what do you typically eat, what is your medical history, your exercise history, and then we draw correlations and results based off of that. Cross-sectional studies are here and now at an immediate moment in time where you gather a bunch of data and then try to identify really what is going on. This is all especially prevalent in things like food safety, food poisoning, infections like viruses, communicable diseases. So that's bacteria and viral. It can also be for things like smoking and the incidence of cancer. Your epidemiological studies are vital for gathering information, but they are not gold standards. They're not like randomized controlled trials because there are so many possible variables that could be considered. It's hard to control for those. They tend to be they tend to be very time consuming, which increases the cost, thinking of like the prospective studies. They can be rigid, which means we can't account for some variables. People tend to drop out of studies when it's, for example, the cross-sectional and the prospective, which means you lose a level of subjects. And therefore, these studies are not always necessarily big on the prospective, but there are some that are absolutely powerful. The doctor study, which is they use doctors to identify that cigarettes equal lung cancer, or the Framingham Heart Study, another excellent one, the nurses study. These are all excellent studies. They went on for years and years, and they used a very large cohort of people that they followed over those years. There are different ways to evaluate these studies. Systematic is going to look at small studies with very strict standards, and that's excellent. Or a meta-analysis will re-review small studies. But folks, you got to be cautious. I got into it with a doctor at Kaiser about this because a meta-analysis doesn't mean that the studies are quality studies. Whenever someone writes a review of these, you still need to go back and look at the studies, or check to see if there's anything that they indicate at the end of the study saying, end of the review, saying that we acknowledge that there was inconsistencies between these studies, or we acknowledge that there were a variety of variables that were not considered in these studies. And they oftentimes will self-appoint this information in their papers and then share it with the public. Okay, a research article, just understanding if you read them. Some people love them. Some people find them drier than your turkey bones sitting out after a few days. I find them painful, but they can provide fascinating information. So the abstract is probably the best place to start. It's cut to the chase on the abstract. They'll give you a brief review of what the conclusion was, and then you can determine if you want to read the study. But things you want to always look for is what was the intention of the study? How did they conduct the study? How many people were included? Because we really want thousands first and foremost, second to that hundreds. But when we're down to singular numbers or 2 digits, that's a really low quality study. We want to know what the conclusions are, and then it is vital for you to look for any type of bias. So that being said, how do we find research bias? Number one, you've got to look for claims in it, anything where they'll state the possibility of the study being funded by a corporation. For example, the research article I have listed here, the virgin coconut oil study, folks, that was actually performed by a university, but all of the coconut was donated by the coconut industry. Well, they can't donate it directly to the university because the moment they do, there's a level of bias. Because obviously the university is going to want donations in the future, which means that someone there has the possible of skewing the results. So you can't, universities are not hands down guarantee that they're good. They usually are, but just be cautious of that. Government agencies, those oftentimes, if they oversee the studies, are going to be quality studies. You want to look for authors who will reference any bias. Do they own stocks in the company? Are they on loan from a corporation that has something to do with the product? Have they written articles or been on the boards of any companies related to this product? This should be disclosed usually at the end of the study. Again, you want to look at how large the sample population is and consider the confounding factors, the variables which may alter the results. And oftentimes they'll list what those could be that might have not been accounted for and could influence the results if they had. Sometimes they don't recognize this until after the fact, or they didn't have the money or time to be able to comprehensively cover everything, or some things just are impossible to monitor. Okay, so as mentioned prior in the supplements section, you got to be cautious because companies that claim that they have research or proof of their products, oftentimes, uh, folks, their proof is false, it's fabricated, or it's very poor quality. That's why we want to really pay attention to the claims people make about studies. All right, examples of claims that were made. First of all, this was really frustrating to me. You have a link down here. I can't remember what in the heck that link was. Go check it out. This was a frustrating article, though, for me. It was, they made the statement that the American Heart Association tells you exactly that despite studies like this prove beyond any doubt they are wrong. Folks, no. Okay? This is just absolutely perverse to think that this is a possibility. I mean, humans make mistakes, yes. Science, nutrition science is changing constantly. So, is there the possibility that the American Heart Association could present information that they have to change, they have to update? Yes, of course that's possible. But the odds of them giving false information intentionally is not the case at all. Now, when you look at the sources list for this claim this person has made, it's absolutely ridiculous. Okay, first of all, they have references like Dr. Mercola's website. Seriously, they have clips from the news. Seriously, the news is probably one of the most corrupt options possible. I mean, it's a riot because I love how they recycle nutrition information that could be 10 years old and they're like, studies present. It's like, folks, this is old news. You're grasping at straws at this point. Oftentimes, too, when they present this information, whether it be newspaper articles, LA Times, or on the news, they take it out of context. This goes back to the 1980s when Time magazine, was saying, don't eat eggs, don't eat butter, it'll kill you. Oh my God. And now they're saying, do eat butter, it's good for you. No, no, no. I, you know, if I could arrest the people who make these claims, I would have more prisons than I know what to do with. Um, you also have to take into consideration that when they reference magazines, Journal of Alzheimer's Disease, Nutrition and Metabolism, without looking those up, there's always the possibility that they could be editorials, which are people's opinions, um, or they could be information that they extracted out of context without explaining the whole topic. And as I said before, this is a situation I had with a doctor at Kaiser where he extracted information from a meta analysis, but obviously did not read the whole darn study because when I went to the bottom of the study, he was saying that we should not be eating chicken. It elevates LDL, our blood cholesterol. But at the end of the study, they acknowledged in the study, the review that is, that the data was not comprehensive and not consistent. And there were too many variables to really make that a science worthy claim. Yet he somehow missed that paragraph. Seriously? So I'm sure the doctor has the best of intentions. He's responsible for a lot of information at Kaiser. But the failure to basically follow through is now emanating out into our population for information. And that's a bit on the frustrating side.